Hey guys, welcome back. So I'm going to get you through Unit 21 about the solar system. If you are following along on the paper, thank you for scanning that QR code or clicking the link or however you got here. Don't forget to put your name on this. So I'm getting some packets back with no names or anything on here, and I don't know who did the hard work and who needs that credit. So make sure to put your name up there. If you are working on this on the computer, you can put your name up in the top by double-clicking up here, and then it will let you edit your name. And you can also put the date. Don't put anything in the score, and that's my job. If you put something in the score, I might just make it a 0. Oh, snizzity snap. Alright, so the solar system. What are the characteristics of the planets in the solar system? How can we classify the planets in the solar system? What are the characteristics of comets, asteroids, and meteoroids? What are some recent inventions and discoveries about the solar system? And what are the benefits of space technology? And we've got a picture of a space shuttle right here heading up out into space. Alright, this space shuttle was launched into space to observe and learn more about the solar system. How do we classify the planets in the solar system? What are the other objects in the solar system? And how has space technology helped us? These are all things that we're going to learn about in this lesson today. Alright, section 21.1, planets in the solar system. What are the characteristics of the planets in the solar system? The planets in the solar system have different characteristics. These characteristics include their orbit, distance from the sun, temperature, and the period of revolution or the time taken to make one orbit. So we've got some bold here. Let's see if it needs to go in our worksheet at all. Yep, the planets have different characteristics, which include their orbit, which was right there, distance from the sun, temperature, and the period of revolution around the sun. So period of revolution is just how long does it take to go all the way around the sun, or what we like to call a year. So the planets can be characterized, that is for the next page, right? Yes, okay. Or the time taken to make one orbit. So here we're talking about Neptune. That one's pretty far from the sun. Distance from the sun, 4,497 million kilometers from the sun. Temperature, just a balmy negative 200 degrees Celsius. A bit chilly. Period of revolution, 164.8 Earth years. So one Neptune year is 164.8, or 164 and 8/10 Earth years. We could round that off to 165 Earth years. So you will not see Neptune make one full complete revolution before your lifetime is over. Uranus. Distance from the sun, 2,870 million kilometers. Temperature, negative 215 degrees Celsius. So it's even colder than Neptune, even though it's a little closer to the sun. Period of revolution, 84 years. So you might be able to see Uranus twice in your lifetime going around the Earth, going around the sun. Saturn. Distance from the sun, 1,427 million kilometers. Temperature, negative 175 degrees Celsius. One Saturn year is 29.5 Earth years. So hey, I have been alive longer than one Saturn year. Awesome. Jupiter, distance from the sun, 778 million kilometers. Its temperature ranges from negative 145 degrees Celsius up to 210 degrees Celsius. So it goes from incredibly cold to twice as hot as boiling water. Its period of revolution is 11 2/10 of a year. And then we've got our sun here. So these were all the planets that are kind of far from the sun. Now we're going to start back with the planets that are closest to the Sun. Mercury, its distance from the Sun is only 58 million kilometers. Its temperature ranges from negative 180 degrees Celsius up to 430 degrees Celsius. It takes about 88 days to get around the Sun, and that's 88 Earth days, not 88 Mercury days. Venus, its distance from the Sun is 1,427 million kilometers. Its temperature is a nice tropical 465 degrees Celsius. That's a little more than 4.5 times as hot as boiling water. I do not want to take my vacation there. The period of revolution, 224 and 65 hundredths of a day. So, a little less than 1 Earth year. Earth, distance from the Sun, 152 million kilometers. Our temperatures range from negative 89 degrees Celsius up to 57 degrees Celsius. Period of revolution, 365 and 1/4 days. Mars, distance from the Sun, 228 million kilometers. Temperature, negative 125 up to 20 degrees Celsius. 20 degrees Celsius, that's, a nice, decent temperature room. Period of revolution, 687 days. So, just under 2 years of Earth years. Orbit. All the planets in the solar system orbit the Sun. This is due to the strong gravitational force of the Sun. As the planets are at different distances from the Sun, their orbits are also different. The further away a planet is from the Sun, the longer is its orbit. So doesn't that kind of make sense? It's going to take you a lot longer to go a big giant circle compared to a smaller circle. Distance from the Sun. Mercury is the closest planet to the Sun, while Neptune is the furthest. The Earth is the 3rd planet closest to the Sun in the solar system. Temperature. The temperatures of the planets are largely determined by their distances from the Sun. So did you kind of notice that Mercury, right up front, it gets up to 430 degrees Celsius? And then Venus, also pretty close, also very hot. It also has what's called the greenhouse effect. So there is a lot of greenhouse gases on Venus, and Venus is incredibly hot. Here's hoping we don't get there. So Earth, we're just about right. It normally does not get to these extremes on places where humans live, but it can. Mars, it's a little chillier than us. 57 degrees Celsius versus 20 degrees Celsius for its average high temperature. So it's getting a little chillier. And then as we go to Jupiter, Jupiter has a lot of hot gases happening. So it has some extra heat. But it does also get colder than Mars or Earth does. Saturn, its average temperature is about negative 175. Negative 145 is the coldest Jupiter got. Negative 175 is Saturn's average. So, more negative means smaller. Uranus, a lot smaller, more negative. Neptune, it probably has some other stuff happening on its surface with its atmosphere, so it's not as cold. But hottest, warm, 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 and then coldest ones back here. So the temperature, not completely determined by the distance from the Sun, but it does have an influence. So generally, the further the planet is from the Sun, the cooler it is. Venus is the only exception. This planet has a thick atmosphere and experiences very high temperatures, even though it is not the closest planet to the Sun. Period of revolution around the Sun. Because the planets are at various distances from the Sun, their orbits around the Sun are also different. The further away the planet is from the Sun, the longer the time it takes to complete one revolution or a longer period of revolution. Okay, classifying the planets. So, how do we classify the planets in the solar system? The planets can be classified by their sizes and composition, as well as their distances from the Sun. So this first group right here is called terrestrial or inner planets. And then we have Earth here. Venus and Mercury are closer to the sun. This is our sun right here. They are closer, so we call them inferior. Earth. And then Mars, Jupiter, Saturn, Uranus, and Neptune. All the planets that are farther away from the sun compared to Earth are called superior planets. These ones are terrestrial or inner planets, and these ones are Jovian or outer planets. Jovian kind of gets its name from Jupiter. Those have to do with ancient Greek and Roman gods and goddesses. Alright, so the size, composition, and distance from the sun. But the planets can be classified by their sizes and composition, as well as their distances from the sun. So planets can be classified by their sizes, composition. So we're back to the assessment page. Their distances from the sun, and their blank to the sun as compared to the Earth. So we haven't gotten that one yet. Let's come down here. So there are 4 planets that are considered small in size. That's not right. And they're blank to the sun. Distances from the sun, and they're blank to the sun. Oh, okay, it's on the next page. Ha! So size, composition, and distance from the sun. There are 4 planets that are considered small in size. With diameters of less than 13,000 kilometers, they are made up of mainly rocks and metals and are known as the terrestrial planets. These planets are Mercury, Venus, Earth, and Mars. So if you think of the ground when you go outside, that's made up of rocks and metals. We call it Earth. We call it ground. We call it dirt. It could also be terrestrial. When you think of all the movies, they talk about, ooh, extraterrestrial. Extra meaning beyond, terrestrial meaning Earth. So beyond Earth. So outside of our planet. So Mercury, Venus, Earth, and Mars, all four of our planets have rocks and metals. So we all considered terrestrial. The terrestrial planets are the planets that are closer in distance from the sun. So they are also known as the inner planets of the solar system. So inner planets. There are 4 planets that are considered big in size, with diameters greater than 48,000 kilometers. They are made up of mainly gases and are known as the gas planets or Jovian planets. These planets are Jupiter, Saturn, Uranus, and Neptune. The Jovian planets are the planets that are further in distance from the sun, so they are also known as the outer planets of the solar system. Proximity to the sun in comparison with the Earth. So this is actually the last part of number 2, proximity to the sun. Because we are talking about ways to classify the planets right now. Okay, so I'm going to keep this available. Okay. We can also classify planets according to their proximity to the sun as compared to the proximity of the Earth to the sun. Proximity is just a fancy schmancy word to say how close you are to something else. So if I am in close proximity, then that means I'm close to something. Right now, we're supposed to be practicing social distancing, so you should not be in a proximity of less than 6 feet from other people, unless they're people that live in your home with you. And even then, come on, personal bubble, people. Alright, so, blah, 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 blah. Mercury and Venus are closer to the sun than the Earth is to the sun. So, due to their close proximity to the sun, as compared to the Earth, they are known as inferior planets. Mars, Jupiter, Saturn, Uranus, and Neptune are further from the sun than the Earth is from the sun. Since they are further than the Earth from the sun, they are known as superior planets. Okay, presence of planetary rings, and presence of moons. So question number 3, the planets can also be classified by the presence of blank and moons. Planetary rings. Ooh, make sure to spell correctly, right? We can also classify the planets according to the presence of planetary rings. Some planets have rings of rocks and ice surrounding them in space. These rings are called planetary rings. Only the 4 outer planets have planetary rings surrounding them. So Saturn, that's the one that we can always remember, has tons and tons of rings. And then Uranus, you can kind of see one, just like gingerly going around it. Jupiter and Neptune, I don't really know if they have very many rings, but this says that they do. So I will look into that for myself, because now I'm curious. Presence of moons. Another way to classify the planets is through the presence of moons, or natural satellites. Natural satellites are small celestial bodies that have fixed orbits around planets. Mercury and Venus do not have moons, while all the other planets have at least one moon. So, Earth has one moon. Mercury and Venus, they're really close to the sun and they do not have moons. But all the other planets, they have multiple moons, or at least one. Some of those moons actually end up getting their own fancy names. Okay, so 21.3, comets, asteroids, and meteoroids. What are the characteristics of comets, asteroids, and meteoroids? Comets, asteroids, and meteoroids move around the sun like the planets do in the solar system. So, comets. A comet is a celestial body. So that's going to go on our paper. It wants 2 words, 2 words. Celestial body that orbits the sun. However, the nucleus of a comet is much smaller than a planet. It usually ranges from a few kilometers to tens of kilometers in length. A kilometer is about 1,000 feet. Tens of kilometers, so maybe 10,000 feet. So that would be maybe 2 miles. So anywhere between 10 kilometers would be a kilometer is about a mile. 10 kilometers would be 10 miles. Okay. So if you think of how often do we have stoplights in Phoenix, we have major intersections about every mile or 8 streets. So a few kilometers would be about 2 or 3 stoplights away on, if you're thinking about the major roads. To tens of kilometers, that would be like not even as big as the city of Phoenix. Okay, in length. So a comet is a celestial body that orbits the sun, but the blank of a comet is much smaller than a planet. The nucleus of a comet is much smaller than a planet. The time taken for a comet to orbit around the sun varies. Alright, so we got that. The time taken for a comet to orbit the sun varies. Some may take less than 100 years, while others can even take more than 1,000,000 years. When a comet comes close enough to the sun, it produces a visible coma or atmosphere. When a comet comes near the sun, it produces a visible coma. And that is pronounced just like coma, or atmosphere, and sometimes a dusty tail. And sometimes a dusty tail. This is due to the heating and evaporation of the ice and dust on the comet. The most famous comet is Halley's Comet. It can be seen from the Earth almost every 76 years. So there's a good chance that you will see this in your lifetime at least once, depending on how long you live. So this right here is a picture showing a comet. So the nucleus, that's the kind of middle center part. And this is the coma around it. And it's dusty tail, dusty tail, dusty tail. And the parts of a comet. The nucleus of Comet Hyakutake, as seen on 25th of March 1996. The comet's nucleus is only 2 kilometers, but its dusty trail is about 500 million kilometers from its nucleus. Asteroids. Asteroids are thought to be fragments of rock left over from the formation of the solar system. They are smaller in size than planets, but bigger than meteoroids. The asteroid belt between Mars and Jupiter contains millions of asteroids. The largest object in the asteroid belt is a dwarf planet called Ceres. A dwarf planet is a nearly round-shaped celestial body that orbits the Sun. It is not a moon. There are 3 large asteroids called Vesta, Pallas, and Hygiea. Do I have that one? Oh, question number 6 was asteroids are thought to be blank of rocks left over from the formation of the solar system. Did you guys catch that one? Fragments. So fragments are just broken chunks or pieces of rocks left over from the formation of the solar system. Okay. Asteroids are blank in size than planets. So they are smaller in size than planets, but blank than meteoroids. I think it was bigger. Yep, bigger. Most asteroids can be found in the asteroid belt between, did we cover that yet? Yep. The asteroid belt between Mars and Jupiter. And the largest object in the asteroid belt is a dwarf planet and it only wants 2 words, but I'm going to say dwarf planet called Ceres. So that's how I'll know that you actually watched this video and didn't just try to do it on your own. So, I mean, you can do it on your own. That's totally awesome and cool. But I took my time to make this, so it makes me feel good if you actually watched it. So I'm going to move this away so that we have to keep on paying attention. Alright, so there are 3 large asteroids. The sizes of the asteroids vary from tens of meters to hundreds of kilometers. Tens of meters would be like 30 feet, 40 feet, somewhere around there, up to hundreds of kilometers, so hundreds of miles. The composition of asteroids is varied and in most cases poorly understood. Many of the smaller asteroids are piles of rubble held together loosely by gravity. Asteroids are believed to contain traces of amino acids and other organic compounds. Asteroids revolve around the Sun in elliptical orbits similar to the planets. Sometimes Jupiter's and Mars's gravitational pulls on them can change the asteroids' orbits and knock them out of the belt. Asteroids may also collide with one another in the belt and cause pieces of them to escape from the belt. Oops. Meteoroids. Meteoroids are made up of similar material as asteroids, but are smaller than them. Question number 10. Smaller. Meteoroids orbit the Sun at various speeds. When meteoroids I have a number 11. Oh, meteoroids orbit the Sun at various speeds. Okay, when meteoroids enter the Earth's atmosphere, they are heated to very high temperatures due to the friction in the air, and they glow. Scientists estimate that each day there are many meteoroids that enter the Earth's atmosphere and reach the ground as meteorites. Meteoroids that reach the ground as meteorites The meteorites may create craters on the Earth's surface. The materials from these craters cool and solidify to become tektites. Not the spider monsters from Legend of Zelda. Sorry, guys. Tektites are generally black or olive green in color. Their shapes can vary from round to irregular. This is an example of a tectate right here. Okay, recent discoveries about the solar system. What are some recent discoveries about the solar system? There are some recent discoveries about the solar system. Let us find out about these discoveries. Solar flares. Some recent discoveries include solar flares, evidence of the presence of water on Mars and the dwarf planet Pluto. Okay, so now I'm actually going to read it for you guys. Okay. Solar flares. A solar flare occurs when the magnetic energy that has built up in the sun's atmosphere is suddenly released as light energy. Solar flares, with their huge amount of energy, can disrupt our radio and satellite communications. Solar flare events can also increase the amount of ultraviolet radiation reaching the Earth's surface, which is harmful to us. Ultraviolet radiation, that's the stuff that causes sunburns, skin cancer, and all sorts of other no good stuff. But it's also the stuff that's in a black light, which helps us to see scorpions, which it's about scorpion season right now, so UV radiation, good and bad. Mars. There have been many space missions to Mars. Each time, the mission has a different purpose, such as researching the weather conditions and geographical landscape, or searching for minerals and the presence of water. Mars is very similar to our Earth. It experiences seasons similar to the winters and summers on the Earth. Scientists have found strong evidence that water once flowed on the surface of Mars. They found gullies and valleys on the planet's surface and think that water may still lie in the cracks of rocks. Recently, vast amounts of ice beneath the surface near its south pole were discovered. Pluto. Pluto was first discovered by an American astronomer named Clyde Tombaugh in 1930. It was once known as the smallest, coldest, and most distant planet from the Sun. Many scientists acknowledged Pluto as the 9th planet of the solar system. However, since 2006, the International Astronomical Union formally downgraded Pluto from an official planet to a dwarf planet. That totally ruined my childhood, guys, okay? Like, I grew up thinking, oh yeah, Pluto's a planet, meh, meh, meh. And then, like, all of a sudden, I'm all grown up, and they're like, no, it's not a planet. I'm like, what? Ruined my childhood. Rude. Okay, so that was question number 13 was Pluto. We are almost there, guys. Benefits and uses of space technology. What are the benefits and uses of space technology? Space technology has helped us to launch spacecrafts into space. Thus, we were able to learn more about the characteristics of other celestial bodies such as the Moon and Mars. Currently, scientists are studying if these celestial bodies can sustain human lives like the Earth. Space missions and development of space technology have also greatly benefited man. They have proved to be very useful. These benefits and uses include medical and health advancements, weather data, new source of energy, engineering, transportation, new materials, and computer technology. So space technology has resulted in the development of other technologies. You could also say advancements or benefits, and I will accept that. Yep. Medical and health advancements. Space technology that was initially developed to monitor astronauts' health has resulted in the development of medical technologies on the Earth. These include pacemakers and cool suits. A pacemaker would be for someone who has heart disease. Maybe they've had a heart attack or two. And a pacemaker is just a little device that goes under your skin at your heart and gives you a little electric shock to help keep your heart beating the way it's supposed to. A cool suit like this. Cool suits are used by athletes who have health issues while training for sports. So all these little swirly design thingies, those would probably be heat sinks to take the heat from your body and help move it away from you so you can cool down a lot quicker and you don't overheat and just like pass out while trying to run. Weather data. Space technology that was initially developed to track weather conditions on other planets has resulted in the development of tracking of the Earth's weather. New source of energy. Space technology has developed the use of solar energy. This has resulted in the development of solar cells. Energy. Engineering. Space technology has developed computer programs for spacecrafts. This has resulted in adaptations of these same programs for everyday use for engineering purposes on the Earth. The transportation industry uses the programs when they develop new models of vehicles. So a new car model is developed using computer programs initially developed for spacecrafts. And that's just some cool looking car. Transportation. Space technology that was initially developed for spacecrafts has resulted in the development of transportation on the Earth. These include improved airplane engines and electric cars. New materials. Space technology has developed new materials that are commonly used today. These materials, such as carbon fiber and other carbon alloys, are lightweight and durable. Computer technology. Space technology has developed many devices for use on spacecrafts. This has resulted in many electrical devices, such as lighter and more portable computers, like a laptop or a Chromebook. And that's it, guys. 30 minutes. Not too bad. This is supposed to take up a whole hour, so kind of think about this. Maybe go on YouTube and find some more videos about space and stars and the sun, and just, explore and enjoy. Thanks, guys.